Okay, today we have a big geometry lesson on angles. You probably know some things about angles already. First, we're going to talk about the measurement of angles. If two non-collinear, remember that means not along the same line, rays have a common endpoint, they form an angle. So that's the definition of an angle. In the picture you can see you have a ray starting at point A passing through point B and another one with a common endpoint of A passing through point C. Those form this angle. The rays are the sides of the angles. So ray AB and ray AC are the sides of the angle. The common endpoint is the vertex. So the vertex is the point A. The vertex is always a point and it's where the two sides of the angle meet. It's also where the V of the angle is, which can help you remember the word vertex. The angle at the right can be named as angle A, angle BAC, angle CAB, or angle 1. So there's 4 different ways to name this angle. It would be wrong to name it angle ABC though, because the middle letter for the angle name has to be the vertex. So notice here A is in the middle and here A is in the middle. Since A is the vertex, A is like the most important letter of that angle, and it has to be the middle letter or the only letter when you name the angle. A right angle is an angle whose measure is 90 degrees. An acute angle has a measure less than 90 degrees. An obtuse angle has a measure greater than 90 but less than 180. So something between 90 and 180 to be an obtuse angle. All right, there's a couple of fully worked example problems here that you can look at if you need extra examples, but we're going to jump down here to the bottom and take a look at these. So the problem says refer to the figure at right, so we're looking at this picture to answer questions 1, 2, and 3. Number 1, name the vertex of angle 4. Okay, so this number 4 is inside of this angle, and the vertex, if you'll remember, is where the point of the angle is. So if you look at the point coming right around angle 4, that would be point B. Next, name the sides of angle BDC. So from B to D to C, what are the sides of the angle? Well, from B to D is 1, line segment BD, and then from D to C is the other side. Remember, the sides are the straight parts that connect at the vertex, and point D is the vertex, but they didn't ask us for that. All right, number 3, write another name for angle DBC. Well, we wouldn't want to just call it angle B, because there are actually 3 angles with a vertex at B, and you wouldn't know which one you were talking about if you just called it angle B, because it could be angle ABD or angle DBC or angle ABC. So we could not really call this one just angle B. But the letters could go in the opposite order. Instead of from D to B to C, we could call it angle CBD. Or another thing that we could call it is the little number that's inside the angle. We could call it angle 3. All right, the next section says classify each angle as right, acute, or obtuse, then use a protractor to measure the angle to the nearest degree. So let's start with angle MPR. Do you think that this angle is 90 degrees, less than 90 degrees, or greater than 90 degrees? Hopefully you thought it is greater than 90 degrees, which means it is an obtuse angle. Remember, a 90-degree angle is open like the corner of your paper, and if it's stretched out wider than that, it's called obtuse, and if it's narrower than that, it's called acute. So we're going to measure this angle now. I'm going to take my protractor and put the middle right down on my vertex of my angle, point P, and line up the right side with the straight line that goes to the right of angle P through that straight line on my protractor. And now looking at where this opens, I see two measurements. I see 60 and 120 from point M. It goes out towards 60 or 120. So you're always going to see two measurements on your protractor when you're measuring an angle. That's why it's important to be able to identify if the angle is a right angle, an acute angle, or an obtuse angle before you measure. We've determined this angle is obtuse, so we're going to choose 120 because that's the number that is greater than 90. If it was an acute angle, we would choose the 60. Also, whichever side your angle is coming from, we're looping around with that side being the 0 and then up to here to 120. So that's how we determine it's 120 degrees. Number 5, angle RPN, from R to P to N. This one is a right angle, exactly 90 degrees. And it is marked with the little 90-degree box on it, so that really helps us to know that it is a right angle. Okay, number 6, angle NPS. So this angle looks to be less than the 90 degrees. It's not stretched out as wide as the NPR, so that's called an acute angle. Now, to measure this angle, I'm going to have to line my protractor up with the bottom side of this angle from P to S. So the straight line will go along the straight line on my protractor. Point P is at the center. And now I'm looking to see where this N is pointing. It's right about here, midway either between the 40 and the 50 or the 130 and the 140. So since it's acute, I want that little measurement midway between, oh, I'm sorry, it is not between the 40 and the 30. It's up here between the 40 and the 50. Okay, so midway between the 40 and the 50 would be a 45-degree angle. And I'm going to choose that, not the 135, because it is an acute angle. So I need a number less than 90. So midway between the end points, midway between the 40 and the 50, so that's going to be 45 degrees. Now, when measuring angles in math class, you know, it's hard, we don't all see the exact same measurement with our eyes. There's a little bit of room for error. I usually do about plus or minus 2 or 3 degrees for accuracy in looking at that. Okay, let's move on. The next page, we have a couple of definitions to go over. Angles that have the same measure are congruent angles. So we have a symbol for congruent. It's the equals with the squiggle over the top. That means same shape, same size. A ray that divides an angle into two congruent angles is called an angle bisector. That cuts it into two equal parts. In the figure, the ray PN is the angle bisector of the measure of angle MPR. Point N lies in the interior of angle MPR, and the measure of angle MPN is congruent to the measure of angle NPR. Notice in the picture that there's some little arcs here. Those arcs are there to show that those two angles are congruent to each other. Since this is the angle bisector, it splits this big angle MPR into two congruent smaller angles. Sometimes you will also see this angle bisector splitting an angle into two congruent angles, and they'll put arcs with a tick mark on them. So either one of those notations would denote that two angles are congruent to each other. And we can also say that the measure of angle MPN is congruent, or sorry, is equal to the measure of angle NPR. So when you put the little M symbol in front, that means the measurement of the angle. So we usually say those are equal because those are denoting numbers, not shapes. And so they would be equal quantities. And this would mean the same thing as angle MPN is congruent to angle NPR. So these mean the same thing, but it's two different ways of writing that those measurements are equal to each other. Okay, we're going to jump down here to some practice algebra problems, and we're going to look at number 2 here. So we're going to take a look at this picture at the right. It says in the figure, QP, so from Q to P, and QR are opposite rays. So that's telling us this forms basically a straight line through these 3 points at the bottom, P, Q, and R. QS bisects angle PQT. So whenever you read something like that, QS bisects angle PQT, what you should do is mark that on the picture so that when you look at it, you know that these two angles are the same. If it's been bisected, it's been cut into 2 equal parts. So I'm going to put the little arcs with the tick marks here on these 2 angles to show, okay, these are the same measurement as each other. Now for number 2, it says if the measurement of angle PQS is equal to 3x plus 13. So I'm just going to write that right here. 3x plus 13 is this angle. And the measure of angle SQT is 6x minus 2. So I'm going to put 6x minus 2 inside of that angle SQT. We are supposed to find the measure of angle PQT. So this that I've circled in the problem is what it is that I'm trying to find. So that's the measurement of the angle going from point P to point Q, then to point T, which contains both of these two. So the first thing we need to think about is what equation could I write that would help me to solve for x in this problem? So when you think of the word equation, it means things that are equal. And we already know that these two angles are equal because we have congruent marks on them. So we can write an equation, 3x plus 13 must equal 6x minus 2, because the information in the problem and our picture that we have marked from it show us that that would have to be a true statement. And now we have an algebraic equation that we can use to solve for x. So there's more than one correct way to solve an algebraic equation. I generally like to start by getting my x's together first. And I like to move the x's over to whichever side has the larger x on it. So in this problem, my larger x is my 6x on the right side, but my 3x is over here on the left side. Now I can't just go moving a 3x to the other side. Since it's being added, I have to do the opposite operation to undo that addition to get it to go over to the other side. So the opposite of adding is subtracting. So I'm going to subtract 3x from the left side, and I'm going to subtract 3x from the right side. So over here, 3x minus 3x is 0. That part is gone, and I'm just left with a 13 on the left. On the right side, 6x take away 3x leaves me with just 3x minus 2. So now I only have my 1x in the problem. I've gotten the x's combined. So now I want to get the regular constant numbers combined on the opposite side away from the x. So I have this minus 2 beside the x. So I want to get rid of that minus 2 by performing the opposite operation. I'm going to add 2 to both sides. So 13 plus 2 makes 15, and that equals 3x. Now, I have 3x and I just want x. I want to get x completely by itself. What this means is 3 times x. So in order to undo that multiplication, I'm going to use division. I'm going to divide both sides by 3 to get that x completely by itself. So 15 divided by 3 equals 5. Now it seems like that might be the answer to the problem because we solved for x, but we need to look back. What was it that they asked us to solve for? They asked us to solve for the measure of angle PQT. So that means we have to plug this 5 back in. So for example, this angle from P to Q to S is 3 times 5 plus 13, which means it is 15 plus 13, which equals 28 degrees. Now, I know these two angles are the same because of the congruent marks. If you want me to show that to you, I certainly can. 6 times 5 minus 2 would give me 30 minus 2 is also 28 degrees. So see, these two angles did come out to equal measures. But the question asked me to find the measure of angle PQT, which is both of them put together. So I need to take my 28 degrees and add it to my other 28 degrees, which will result in 56 degrees. Okay, now we are going to move on and look at some angle relationships. We have some important vocabulary here to look at. Pairs of angles is the name of the game here, pairs of angles. So adjacent angles are two angles that lie in the same plane and have a common vertex and a common side, but no common interior points. So adjacent angles means angles that are side by side. So an example of some adjacent angles would be if I had an angle here and then sharing this endpoint and this side is another angle. So let's see, A, B, C, and D. Angle A, B, C is adjacent to angle C, B, D. So you could say whoever sits next to you in class is sitting adjacent to you, or your neighbor who lives next door. You could also say your neighbor lives adjacent to you in the house next door or in the apartment next door. That's an adjacent home. So the next thing we're going to talk about here is a pair of adjacent angles, so two angles side by side, with non-common sides that are opposite rays. Remember, opposite rays is when they form a straight line, is called a linear pair. Okay, so I'm going to show you what that looks like. I have a straight line, so opposite rays, and then I have two adjacent angles that come together to form that straight line. So this angle and this angle make a linear pair. Notice the root word line. They come together with their non-common sides to form a line. Their common sides just kind of split it into two parts. So a linear pair shares a side. The two angles share a side and form a straight line with their non-common sides, with their non-shared sides. So if I were to put letters on here, let's see, E, F, G, H, angle E, F, G, and angle G, F, H form a linear pair. Okay, now the last pair of angles that's an important vocabulary word for us to learn today is a pair of vertical angles. They are two non-adjacent angles, so not side by side, that are formed by two intersecting lines. Basically, whenever you have an X, so two lines crossing, you form vertical angles. The angles that are opposite from each other are vertical. Now you might think vertical also means up and down. So you might think these two are vertical angles, and they are. But there's also another pair of angles that go from here to here. These are also vertical angles. So they don't have to be up and down. If I turned my paper right now, they would be. So the orientation is not so important. What's important is that they are sharing a common vertex but no common sides, and they are opposite from each other when we have a pair of intersecting lines drawn. So There are some examples that are fully worked out here. I want to review the word supplementary and complementary with you. These are probably words you've heard before, but it may have been a while. Supplementary angles are angles that add to make 180 degrees. And complementary angles are angles that add to make 90 degrees. So two supplementary angles would add up to make 180 degrees. In the picture, EFG and GFH, they make a straight line between the two angles, so that's 180 degrees. Then the next one, complementary angles, the measure of angle CBD plus the measure of angle DBE is equal to 90. How do we know this is a right angle? Well, there's a right angle here over on the opposite side, and since this is a straight line, 90 plus 90 would make your 180 for your straight line. So this is a right angle over here on this side as well. Okay, so down at the bottom, we have to name an angle or an angle pair that satisfies each condition. Number one, two adjacent angles. So there's a lot of choices that are correct in choosing two adjacent angles here. Any two with a common vertex that share a side would work. So I'm just going to choose two, but you might choose two different ones. Angle LTR and angle LTE. LTR and LTE. Those are adjacent angles. They share this side LT. Now, two acute vertical angles. Remember, vertical angles are formed by an X, so you need to look in the picture to see where you see an X. And we have an X going from point R to E and then L to S. So we form four angles there. The 110 degree angle, the one opposite it, and then these two are acute that are across from each other. They want the acute ones. So we're going to say angle RTS and angle LTE. Okay, two supplementary adjacent angles. Well, supplementary means they add up to 180, so they make a straight line. So you could choose along the top or the bottom. I've already been using these angles on the top more, so I think I'm going to go with the ones on the bottom. Angle RTS is supplementary and adjacent to angle STE. So they share the side TS, and their non-common sides form a straight line, so they add up to 180. All right, number 4. This could also be called a linear pair, by the way. Two supplementary adjacent angles. Just like we talked about above, they share a side and they form a straight line. Okay, number 4. An angle supplementary to angle RTS. Well, we just kind of did that, STE, so that would work. But the other angle that's also supplementary to it is RTL. Angle RTL makes a straight line with angle RTS, so they would have to be supplementary. They would have to add up to 180 degrees. Every straight line is 180 degrees. Okay, we're gonna, at the bottom here, take a look at the first two problems. Identify two obtuse vertical angles. So this is similar to the problem 2 above, except for this time instead of two acute vertical angles, we're looking for two obtuse vertical angles. So first I just want to find intersecting lines. Whenever I look for vertical angles, I'm looking for a big X. So ST crosses UR. So there's my big X. And there's 4 angles formed, top, bottom, left, and right. Which ones are the obtuse angles? it looks like the bigger ones are the left and the right. So this would be angle RNT and angle SNU. Okay, number 6, identify two acute adjacent angles. So two angles that are side by side but are less than 90 degrees. So we're looking for two small angles that share a side. I'm seeing R and V and V and T. Angle R and V and angle V and T. Okay. Moving along. At the top it says perpendicular lines. Lines, rays, and segments that form four right angles are perpendicular. The right angle symbol indicates that the lines are perpendicular. So you see the little square in there, that means they're perpendicular. In the figure at right, line AC is perpendicular to line BD, and this is the shorthand way to write this with symbols in math. An upside down capital T means is perpendicular to, which means that they make a 90-degree angle. Whenever you see that upside down capital T, you're going to go, oh, okay, I know that has to be a right angle. A, C, and B, D meet at a right angle. Actually, 4 right angles. All of them are right angles, but we usually only draw one. Okay, so down here at the bottom, we're going to do a little bit of practice. There is one fully worked example there if you need extra to look at. But we're going to go down here and do 2, 4, and 5 together. Okay, so for number 2, it says find the measure of angle MSN. Well, MSN is marked with a 90-degree angle box, so it has to be 90 degrees. Woohoo! Done with that one. Number 4, if the measure of angle EBF is 7y minus 3. So I'm going to write 7y minus 3 here in the picture. And the measure of angle FBC is 3y plus 3. Find the value of y so that BE, ray BE, is perpendicular to, that upside down capital T means it is perpendicular to ray BC. Okay, if these form a right angle, then these two would have to add up to equal 90. So we're going to need to write an equation to find the value of y. This is what we're trying to find in the problem. What is the value of y? So these two are complementary angles. They add up to equal 90. So our equation would be 7y minus 3 plus 3y plus 3 equals 90 degrees. And now we need to solve for y. We have 7y and 3y on the same side of the equation. Those are like terms, so they can be added together. 7y plus 3y is 10y. We also have a negative 3 and a positive 3, which add up to 0. So we can just leave it with 10y. And then that has to equal 90. Now this means 10 times y equals 90. And if I want the y all by itself, I have to undo the times 10. So the opposite of multiplication is division. So I'm going to divide by 10 on both sides of the equation. So that'll leave me with y equals 9. And that's the answer for number 4. Okay, number 5. Find the value of x, the measure of angle PQS, and the measure of angle SQR for this picture here. So this problem has not 1, not 2, but 3 answers to the problem. So first let's look at what we could write as an equation to solve for all this stuff. Well, I see two angles, PQS and SQR, that come together at point Q to form a 90-degree angle, which means they're complementary. So they have to add up to equal 90. So I'm going to say 3x plus 8x plus 2 equals 90. These two add up to 90. Now I'm going to combine the like terms. 3x and 8x equals 11x added together, plus 2 equals 90. Now I have to get my x by itself. So I have an 11 to get rid of and I have a 2 to get rid of. Which do I get rid of first, or does it matter at all? It does matter. You have to get rid of the 2 first. It is reverse order of operations when you're solving equations. So we will have to take care of the plus 2 before we take care of the 11 times x. What is the opposite of adding 2? Subtracting 2. So we're going to say 11x equals 90 minus 2, which is 88. And now to get the x by itself, we have to undo the times 11, which would be division, to divide by 11 on both sides. So 88 divided by 11 is 8. X equals 8 is the first answer to this problem. Now, they also want the measure of angle PQS. PQS is 3 times x. So now that we know that x is 8, we do 3 times 8. And 3 times 8 is 24 degrees. And now the measure of angle SQR is the last answer for this problem. SQR is 8x plus 2, so 8 times 8 plus 2. That's 64 plus 2 more makes 66 degrees. Or another option could have been to say 90 minus 24, because these are complementary angles and they have to add up to 90. Alrighty. So now we're going to do a little bit more fun constructions where we get to create very accurate mathematical pictures from nothing but a compass and a straight edge and a pencil. And I seem to have misplaced my straight edge. Had it here a moment ago. Well, technically you could use anything for a straight edge. It's straight. It doesn't have to be a ruler. So I'm just going to take a piece of paper that I was writing on a moment ago, fold it a couple times, and use this as my straight edge. So I'll highlight a side of it so that you can see the edge more clearly. There we go. Okay, so we're going to follow the steps on this construction for duplicating an angle. So the first step, and duplicating means copying, like creating a it's like when you Xerox something in a copy machine. It just makes something that looks exactly the same. So that's what we're going to do. We're going to make an angle that looks just the same as this, except for we're not going to need to use a protractor to measure it. We're going to follow the steps to construct it. So we're going to start by drawing a ray with an endpoint O. So I'm going to use my fancy folded up paper straight edge here. Works pretty good. To make an endpoint of O, and put the arrow over here. There's my ray, endpoint O. Now we're going to draw an arc with a center at point E, so this point E over here on this angle. Yes, we're going to mark the original angle up, which intersects both sides of the angle. So I'm going to take my compass and I'm going to open it up. How far? Well, it doesn't really say. I would recommend going more than halfway, and then we're going to swing an arc that crosses both sides. Okay? Now, I'm going to keep my compass at this measure and not adjust it because I'm going to need it on the next step. Well, maybe not the next step, but the one after that. Label the points of intersection as D and F. So this intersection point will be D, and this intersection point will be F. Now, Number 4, in the directions it says keeping your compass rigid. That means don't adjust it from where it was on the last step. Put the sharp point on O and draw an arc. So I'm going to put the point on O and I'm going to make an arc. How big? Well, I need it to be about the same size as this one, maybe bigger. Definitely not too small or it won't reach as far as it needs to. Then step 5 says label the point of intersection as B. So this intersection point will become my point B. And then step 6 says measure segment DF with your compass and make a mark. So I'm going to take my compass and now I am adjusting it, and I'm going to adjust it so that when I put the pointer on F, that the, I dropped my compass. The pencil will hit point D, and I'm going to make an arc. This arc would be graded if I take a grade on your construction of this, to make sure that you did accurately take that measurement using your compass. Now, step 7 says keeping your compass rigid, so don't adjust it. Make a mark, put the sharp point on B and make an arc that crosses the previous arc that was already here. So we make a little X. And this point of intersection of the two arcs is point G. Now the last step, step 9, says draw the ray from O through G. Point O is the end point. Point G is where I'm headed. Get this all lined up nicely with my fancy straight edge, my folded piece of paper. There we go. Make my ray. Now, these two angles are duplicates of each other. You can measure them with a protractor, and I've lost my protractor. But this angle is congruent to this angle. So the measure of angle DEF equals the measure of angle GOB. Or you can say angle DEF is congruent to angle GOB. We just created an angle that's exactly the same size as the original using a compass and a straight edge, no protractor. But if I had my protractor, oh, there it is. See, it's clear, so it's hard to see. So now I will measure it. So it looks like the original angle was a cute 64 degrees. Oops, there you go, so you can see 64 degrees. Now I'm going to come over here to my new angle that I just made. Get it all lined up, vertex, straight side. And this angle is also 64 degrees. Voila! Isn't that something? Okay. Our next construction is going to be constructing an angle bisector. So we talked about angle bisectors today. I'm going to show you how we can accurately make an angle bisector on this angle A. So the first step is to draw an arc with the sharp point of the compass on point A that intersects both sides of angle A. So my pointer is on the vertex, and I'm going to make an arc that goes through both sides. How far? Middle, further maybe, not too close to point A. So now step 2 says label the points of intersection X and Y. So this top point is point X and this bottom point is point Y. Step 3 says with the sharp point of the compass on X, draw an arc in between the two rays of angle A. So I'm going to put my pointer on point X and make an arc that goes between the two rays. Now let's say your arc was further out. You can still make the arc that would pass where, notice these rays have arrows, they go on forever, where it would be between the rays, they just may not extend as far. Then step 4 says keeping your compass rigid, so do not adjust it. Draw an arc with the sharp point of your compass on Y that intersects the previous arc. So the pointer goes on Y, and I make an arc with the same measurement on my compass that crosses the first one. So there's a little X right in the middle of these two sides of the angle now. And it is in the middle. That's the whole idea with making a angle bisector. Now, label the intersection as point Z. So this point is point Z. And now last, we're going to draw a ray with an endpoint A that passes through Z. So I'm still using my fancy straight edge here. Point A is one end. Point Z is where I'm headed. So I'm going to extend my ray like that. And this split the angle into two congruent smaller angles. That's what an angle bisector does. It passes through the middle of the angle. So I have angle XAZ is congruent to angle ZAY. Or the measure of angle XAZ is equal to the measure of angle ZAY. And these congruent marks show that is what we did. All right. The next construction that we're going to talk about is constructing a perpendicular from a point to a line. What does that mean? It means I want to make a line that goes through point P that meets this line drawn on the paper at a 90-degree angle. Okay? So, first step, with the sharp point of your compass on point P, draw an arc that intersects the line twice. So the measurement for our compass is sort of particular. If it's too small, whoops, it helps if you have extra paper underneath your paper that you're working on when you're doing constructions, because if it's on a hard table or desk, it will just slide around. So there we go, got some extra paper underneath now. So like I was saying, if your compass measurement is too small, it's not going to reach the line. And if it's too big, it won't be able to cross it twice because it'll go beyond that compass, that end of the line. So we want to make like a little smiley face curve arc that will cross through our line twice. So you may want to kind of do a little practice swing before you put your pencil down, just to make sure that you like the size of your compass. So there's my little smile, crosses through the line twice. We're going to label the intersection points R and S. So this will be point R and this will be point S. Now it says, draw an arc with the sharp point of your compass on point R below the line. So I'm going to take my compass with my pointer on R and make an arc down here below the line. Keeping the compass rigid, draw an arc with the sharp point of the compass on S below the line. Make sure the two arcs intersect. So moving my pointer over to S now, I'm going to swing another arc that crosses the first. I now have an X down below point P. This intersection point of these two arcs is point Q. And last, we're going to take our straight edge and draw a line through P and Q. So lining up, there's point Q, there's point P, and make a straight line. Put arrows on the end to show it is a line that goes on forever. And how do I show that these are perpendicular? Do you remember the symbols that we use? We draw a little 90-degree angle box, and we can say line PQ, upside down capital T means is perpendicular to line RS. There we go. All right, this is our last construction and our last example for today's lesson, and it is constructing a perpendicular to a line through a point on the line. So this one is a whole lot like the one we just did, except for instead of point P was above the line last time, now we're working with this point Q, which is actually sitting upon the line. So what we're trying to do is make a 90-degree angle with a new line passing through point Q that is perpendicular to the line we're starting with here. So it says, step 1, with the sharp point of the compass on Q, draw 2 arcs that intersect the line. There should be 1 arc on each side of point Q. So we're going to make sure that our compass is open so that it could cross this line twice. Put our pointer on point Q, and we're going to make a smile just like we did before. Oops, it would help if I put the pointer on point Q and not the pencil. So we're going to make a smile that crosses our line twice. Label the points of intersection A and B. So here's point A, and here's point B. Step 3, make your compass larger than segment AQ. So this step is the one that's a little different from before. On the last problem, it didn't say make it larger. You could leave it the same, but on this one, I can't leave it this measurement AQ. I have to open it wider now. How much wider? Just stretch it out a little bit more. It's not a precise measurement, it just has to be bigger. And so make your compass larger than segment AQ, and then draw an arc with the sharp point of the compass on A. Okay, so I'm moving my pointer over here to A, and I'm going to make an arc, whoops, tearing a hole in my paper. Make an arc down below point Q, below the line. So there's my arc with the pointer on A. Now I'm going to move the pointer over here to B and make another arc below point Q. And the point of intersection where they meet is point R. All right, so I kept my compass rigid, had the pointer on A, swing an arc there, had the pointer on B, swing an arc there, they meet at point R. Now the last step is to draw a line through Q and R. So take my fancy straight edge, line up point R and point Q, draw my line, put arrows on the end to show it goes on forever. And now I'm going to mark it up so that we know it's a perpendicular, which means a 90-degree angle, right angle box. And we can say line QR is perpendicular to line AB. Arrows on these since they go on forever. Okay, I hope you had some fun learning some geometry with me today, and I hope you have an absolutely wonderful day. Good luck on your assignment, and please let me know if you have any questions or if you need any help at all. Bye for now.